Notes for decreasing sequences. Notice the sequence above starts at 56, moves to 48, and then moves to 40. This sequence is getting lower as we go. The change, if you look, between 48 and 40 is 8. The change between 56 and 48 is 8. So our sequence is losing 8 every term. So on the chart, we need to find the first term. Since the sequence is going down as we move down the table, to move up to the 0 term, we would add 8. So 56 plus 8 is 64. The fourth term in the sequence would be 40 minus 8, which is 32. To write the equation of the sequence, remember, we start with t sub n equals, then we do the change, which is negative 8 times n, and then plus the 0 term. So our equation is t sub n equals negative 8n plus 64. 64 came from the 0 term, the negative 8 came from the change. Then we pick a term and prove that it works. So I'm going to pick the second term. So I would do negative 8 times 2 plus 64. Negative 8 times 2 is negative 16, plus 64 is 48. And in our table, the second term is 48. So my equation is correct. For the second example, the sequence is going from 28 to 21 to 14. We are losing 7 between every term. To find the 0 term, I simply add 7 to 28, which is 35. Continuing the pattern to the fourth term, I would subtract 7 from 14 and get 7. My equation would be t sub n equals the change times n plus the 0 term. So again, the 0 term gives me 35, the change gives me negative 7. Picking a term to see if it works, let's pick the second term again. So I would plug a 2 in for n, and then add 35. Negative 7 times 2 is negative 14, and negative 14 plus 35 is 21. Since the second term of our sequence is 21, I know I am correct. For the third example, you'll notice the sequence goes from 95 to 89 to 84. We are losing 5 per term. So to find the 0 term, I simply add 5 to 94, giving me 99. To find the fourth term, we're going down 5 every term, so 84 minus 5 is 79. To write the equation for the sequence, I start with t sub n, the change, negative 5n, plus the 0 term, 99. Again, the 0 term gives us the 99, the change gives us negative 5. Picking a term to prove that it works, let's pick the third term this time. So it'd be negative 5 times 3 plus 99. Negative 5 times 3 is negative 15, and negative 15 plus 99 is 84. The third term is 84, so I am correct. For our fourth example, you'll notice the sequence goes from 100 to 94 to 88. We are losing 6 every term. So to fill in the 0 term, I would add 6 to 100. To get the 4th term, I would continue the pattern of subtracting 6 and get 82. The equation would be T sub n equals the change, negative 6n, plus the 0 term. Now to prove that it works, I'm going to choose the 2nd term this time. So I'm going to plug a 2 in for n. Negative 6 times 2 is negative 12. And negative 12 plus 106 is 94. Since the 2nd term is 94, I know that I am correct.